Your subscribe keeps us motivated. Subscribe now.
A particle leaves the origin with an initial velocity u is equals to 3I meter per second and constant acceleration a, which is equal to minus I minus 1 by 2j meter per second square. Its speed when its x coordinate of position is maximum. So here we will understand the concept of maxima and minima at the end. Let's understand what is given here. So here, as per the question, our initial velocity u is given as 3I meter per second, correct? This is our initial velocity and that too is given along x-axis. Acceleration a, that is given here as minus I minus half, okay, j meter per second square, meter per second square. This is our acceleration given. Now let's split it in terms of x and y coordinates so that we can simplify it much simple, because at the end the question is saying its speed when its x coordinate of position is maximum. So at the end we will have to use x coordinate. So let's start it with the initially x and y coordinate only. So let's write here, given here, what is our initial coordinate of u along x-axis? That is our 3 meter per second. Initial velocity along x-axis. Now, anything else is given? Initial acceleration along x-axis. Acceleration along x-axis is minus 1 meter per second square. Look at here, acceleration, this is our, here, minus 1. Okay. Now, what is our VOY? Okay. Final velocity along y-axis, that is our, initial velocity along y-axis, that will be how much? 0. Let me just write it as UOY. So, that will be our 0. And what is our acceleration along y-axis? That is our minus 0.5 meter per second square. So, from where you got 0.5? Look at this. Half is nothing but 0.5. Correct? And that too negative. These are the information given. Now, final velocity will be Vx, that is equal to Ux plus Axt. We will make use of this formula. And Vy, we will write it as Uy plus Ay. Or you can more modify it according to the data given here, u naught x and u naught y. So these are the equation we will make use here while finding the velocities along x and y. So here, what is u naught x? That is 3, and ax is 1. So minus 1, that is our final velocity along x-axis. And final velocity along y-axis will be, what is u naught y? 0 and a minus 0.5 p. So we got this. This is our equation 1 and this is our equation. Let's read the question. They are saying its speed when its x coordinate of position is maximum. So when they are talking about x coordinate is maximum, which means first derivative, be very careful, maxima minima, first derivative dx by dt must be 0. And what is dx by dt? That is nothing but Vx, that will be equal to 0. So what is Vx from equation 1? Equation 1, Vx is 3 minus t. So putting x as 0, this will be 3 minus t. And t will be equal to 3 seconds. So time was 3 seconds when x coordinate is maximum. And when x coordinate is maximum, they are saying what will be the speed. Now see here, Vx is 0. Already we have taken because it's a maxima condition. Then speed is only contributed by whom? By equation number 2. That is Vy. So Vy will be equals to how much here? Minus 0.5 into 3. So that will be equals to minus 1.5 j. Let's see if there is any option. This is the only, yes, option B, 3 by 2 meter per second, that is 1.5. They have written the magnitude.